Yes, students, let us continue. Let us continue with our 5-mark question series on double derivatives. So, here we have y is equal to tan inverse of x whole square. Show that x square plus 1 whole square into y2 plus 2 of 2x x square plus 1 y1 is equal to 2. See, before I start the problem, we know that d by dx of x power n is n x power n minus 1. Also, when this is applied, d by dx of f of x to the power of n can be written as n f of x to the power of n minus 1 into d by dx of f of x. So, this is the basics. So, function to the power of n I am going to apply here. So, y1 can be written as n function to the power of n minus 1, which is 2 minus 1, into d by dx of function. So, 2 tan inverse of x to the power of 2 minus 1 into d by dx of tan inverse of x. So, let us continue. So, y1 is equal to 2 tan inverse of x. So, what is differential of tan inverse of x? 1 by 1 plus x square. Now, I am going to cross multiply here this value. So, it will be y1 into 1 plus x square is equal to 2 tan inverse of x. Again, I am going to differentiate with respect to x. Here also I have done that. So, differentiating with respect to x. Again, I am going to differentiate. Students, if you just observe, this is of the form UV rule. So, u v dash plus v u dash we have to do. So, u v dash differential of 1 plus x square will be 0 plus 2x plus v 1 plus x square into differential of y1 will give me y2, which is equal to 2 into 1 by 1 plus x square. Just cross multiply this term to the LHS. So, that will become, see, y1 into 2x will be there, plus 1 plus x square into y2 will be there. So, I am going to cross multiply this term to the LHS. So, this will be 1 plus x square, this is nothing but 2. So, when I multiply the values now, I am going to get this particular equation. So, 2x y1 plus 2x y1 into 1 plus x square plus 1 plus x square the whole square, 1 plus x square into 1 plus x square will give me 1 plus x square whole square into y2 is equal to 2. So, this we are proving. This is what is required. Take down, students. Okay, we are moving to the next problem. Similar problem here. So, we need to find 1 minus x square into y2 minus x into y1 is equal to 0. So, differentiating with respect to x, y1 is equal to 1 by root of 1 minus x square. So, this is the ready formula we have here. So, now we are going to cross multiply the term is equal to 1. So, again I am going to differentiate with respect to x. This is of the UV form. So, I am going to apply the uv dash plus vu dash, the product rule here. So, what will happen? So, y1 into differential of root function. So, let me give the basics of that. See, d by dx of root of x is 1 by 2 root of x, students. The same rule when it is applied to a function, it is written as 1 by 2 root of function into d by dx of function. This is what we call as chain rule. So, y1 into 1 by 2 root of function into differential of this function. differential of 1 is 0, differential of x square is 2x, plus square root of 1 minus x square, differential of y1 will become y2. Remember, d by dx of y1 will give me y2 is equal to differential of 1 is 0. Now let me rearrange the terms properly. So minus 2x y1 divided by 2 root of 1 minus x square plus y2 into root of 1 minus x square is equal to 0. 2 is getting cancelled. Take root of 1 minus x square as your common LCM. So minus x y1 plus y2 into root 1 minus x square into root 1 minus x square will give me 1 minus x square is equal to 0. Now 0 into square root will give me, this implies this into this will become 0. So I am left with only the LHS. So y2 into 1 minus x square minus x y1 is equal to 0. This is what required here. So I can say proved. Take down, students. Now the same problem can be done in a different way also. So let me write that. So let me call it as method 2. Till here it remains the same, there is no difference. See, I will take the same value, y is equal to sine inverse of x. So y1 is equal to 1 by root of 1 minus x square. Now you cross multiply, y1 into root of 1 minus x square is equal to 1. Now after this stage what I will do, I am going to square this. So squaring, I am going to get the answer as y1 square into 1 minus x square, square root is getting cancelled, is equal to 1 square, which is nothing but 1. So this is y1 square. So again I am going to differentiate with respect to x, I will arrive at this answer. Very simple, this is also UV rule format. So y1 square into differential of 1 minus x square will give me 0 minus 2x plus 1 minus x square into what is differential of y1 square, that is important. So what is d by dx of y1 the whole square is given by 2y1, okay, function to the power of n function to the power of n minus 1 into differential of y1 will give me y2. So into 2y1 y2 is equal to 0. So minus 2x y1 square plus 2y1 y2 to 1 minus x square is equal to 0. We can take 2 common. Yes, we can take 2 common. Also we can take y1 common. So this will give me minus x y1 plus y2 into 1 minus x square is equal to 0. So 0 by 2y1 will give me again 0. So I am left with this value. So minus x y1 plus y2 into 1 minus x square is equal to 0. So by rearranging I will get the same term, 1 minus x square into y2 minus x y1 is equal to 0. This way also you can solve the problem. Make a note of it. Students, if y is equal to cos inverse of x, find d square y by dx square in terms of y alone. So in terms of y alone means in the final value we must have only y in terms of y alone. So, final result must contain only y. So, very simple. So, in inverse trigonometry, whenever we have y is equal to cos inverse of x, when cos inverse comes this side, this implies cos y is equal to x. Same thing I will do here also. I am going to take this to the LHS. So, this will imply cos y is equal to x. Now, differentiating with respect to x, because I want dy by dx, then d2 by d square y by dx square. So, differential of cos y is minus sin y into dy by dx. Again chain rule is applied. Here minus sin y into differential of y will be dy by dx is equal to differential of x is 1. Now, I can write dy by dx as minus 1 by sin y by cross multiplying. Again I am going to differentiate with respect to x again. So, this fellow will become d2y by dx square is equal to, I am going to apply the quotient rule here. If you are thorough with 1 by x, that also you can apply, which is 1 by function, or you can apply quotient rule, anything. So, here I am going to apply quotient rule for a change. So, what is quotient rule? D by dx of u by v is equal to v u dash minus u v dash divided by v square. This is the quotient rule. And what is that d by dx of 1 by x rule? Minus 1 by x square. Whenever we have a function, minus 1 by function square into d by dx of function. So, I am going to do the quotient rule method as I told you. This also you can do, your wish, your comfort level. So, I am going to do this. So, minus is taken outside, denominator into d by dx of numerator minus numerator into d by dx of denominator. D by dx of sin y will be cos y into dy by dx divided by denominator the whole square. So, this will give the value, I am going to write it here. D square y by dx square is equal to 0 into anything will become 0 minus, let me keep it outside only, 0 into anything is 0 minus cos y into dy by dx. Dy by dx is minus 1 by sin y. So, into minus 1 by sin y whole divided by sin y the whole square. So, now if you just observe, minus into minus plus, plus into minus minus. So, I am going to get minus cos y divided by sin y into sin y the whole square. Now, you can keep it in any format. So, if you know trigonometry, you can write it as minus cot y into cosecant squared y. Sin squared y can be written as cosecant squared y, or you can also write it as cos y into cosecant cube y. Same thing, you see, minus cos y as it is. So, this will become sin cubed y, which can be written as minus cos y into 1 by sin is cosecant. So, it will become cosecant cubed y. Both are correct. So, any value you can keep, it makes no difference. It is just play with trigonometry. So, this will be the answer. Both are correct. Sir, which one to keep? You can keep this if or this, no problem. Okay, students, let us continue. See, this is the problem, and we need to prove y2 minus 5y1 plus 6y is equal to 0. No problem, you can write d2y by dx square as y2, dy by dx is y1, both are same. Differentiating with respect to x, so I will get dy by dx is equal to 3 into e power 2x, differential of 2x is 2, plus 2 into e power 3x, differential of 3x is 3. So 6 e power 2x plus 6 e power 3x is your dy by dx. So again I am going to differentiate with respect to x. So dy by dx is equal to 6 into e power 2x into 2 plus 6 into e power 3x into 3. 12 e power 2x plus 18 e power 3x. Now I am going to take this LHS, substitute the values. So LHS d square y by dx square, this will be d square y by dx square, students. Double derivative I am doing, I forgot, d2y by dx square minus 5 dy by dx plus 6y. Substitute this value, 12 e power 2x plus 18 e power 3x minus 5 into 6 e power 2x plus 6 e power 3x plus 6y, take this y as this value, 3 e power 2x plus 2 e power 3x. Now what? Dishum, 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 shoot out everything, it must get cancelled. So let us see whether they will get cancelled. 12 e power 2x, 18 e power 3x minus 30 e power 2x minus 30 e power 3x plus 18 e power 3x plus 12 e power 3x. So now e power, this is 2x, 6 is 18 e power 2x, okay. 12 plus 18 will give me 30. So 30 minus 30 will be 0. 12 plus 18 will give me 30 e power 3x minus this will give me 0. So final answer will be 0. So 12 plus this, so let me write the steps, 30 e power 2x minus 30 e power 2x plus 18 plus 12, 30 e power 3x minus 30 e power 3x. So cancelling, I will get the answer as 0 RHS. So these are the problems in from NCERT exercises, so which are eligible for 5 marks for all the board exams, your respective state board exam. So we can expect these kind of problems, students. So look for the more videos, I will be releasing a lot of videos further. So make a note of this. So before you start the class, keep your pen and paper ready and start solving. Wherever you want to pause it, pause the video. If you have any doubts, put it in the comments. So we will go through it. Okay. Bye, students.